Hi, everyone. Welcome. Thanks for joining us on the second day of Build. I hope you're enjoying your event. I know you guys are only here for the button. We did give away some of the buttons. And we had some in the booth. We had a line, actually, at 10 a.m. before the booth area opened, just for us. Thanks very much for the attention. I have good news and bad news. Good news is that you can buy the buttons online from the Texmo website now. Bad news is that it's coming from Germany. It's expensive. So we're working with the guys from Texmo to get the prices down, so you'll be able to buy them. We will still have something like 100 and something tomorrow morning on the booth. We're creating the demand every day, some more buttons for you guys to come over and over again. We'll be three of us talking today. I'm not Andrew. I'm the last one in the list. Andrew will be talking just after me. Chris will take over to close with cool demos. The idea of this session is to introduce you to what we call the platform services for Azure IoT, and then tell you more details what this is about. If you have questions and want to interrupt, you can. I speak super fast usually, especially if I have a lot of demos and two guys bigger than me are waiting to take the podium. So I'm going to try and answer your questions. I might not see you, though, because we have big lights here. But you can also reserve your questions for the end, and we can answer them. We are on Twitter as well if you want to find us. We cannot hide. We're in plain sight. You can find us over there on these aliases. I'll introduce what we call the platform services for Azure IoT. We'll talk about IoT Hub. I'll talk about device provisioning service. And then I'll hand over to Andrew for time series insights, and then to Chris for Azure Maps. You happen to have the two PMs for these two fantastic products here, so you can grill them on everything there. I'm not the PM for IT Hub. Don't grill me. So for the few of you, will have a button that was given at the entrance. Don't try and set it up, because it's already set up to connect to the Microsoft Wi-Fi here and to send a message to a specific IoT hub of ours so that we can track you during the, no, we're not tracking you during the event. What you're going to do actually is feed something fun. If you like something during the session, click on the button. That's an experiment. Maybe Wi-Fi will drop. Maybe it's going to be a catastrophe. I will look ridiculous when I will bring up the web page that shows your clicks. But if you're happy with the session, you like something, you click, and then we'll see something will happen. As mentioned on the slide, don't click on it like your life depends on it, right? Buttons have a nice battery lifespan. I think they will last 500 clicks. I'd be happy if battery is dead at the end of this session. That means we're doing a good job. I don't think you're going to have time to click. You'll see the green light that's going to flash. That means it's trying to find Wi-Fi. If it's successful at connecting to that IoT hub and sending a message, it'll finish with a steady green light and then off. If it fails, it's going to be red, and we can blame the Wi-Fi. OK, guys. So Azure IoT. We are talking about tons of things when we talk about Azure IoT. For those of you who were at Sam's session yesterday, how many of you went to Sam's session? And you got a button, right? Not all. Damn it. So we talked about lots of things during that session. We're going to drill down a bit deeper into some of these things. We are talking now about Azure IoT in three areas. The first one is solutions. So we have solutions that for some of them are turnkey type of experiences, SaaS type of experiences that will help you get started in minutes. And when we say minutes, you can come down to our IoT Central booth, and you'll see how fast you can set up an IoT Central application and start connecting devices, start sending data, applying rules, displaying that data in real time, and then triggering flows in your line of business application. And then we have the Azure IoT Solution Accelerators, previously known as Azure IoT Suite. It's a set of pre-configured solutions that allow you to get started faster with PaaS services that then are deployed onto your own Azure subscription, and then you can go and customize at will. The platform services are these PaaS services. If you want to think of it as a box of Legos, right? You like Legos. You're going to aggregate these fantastic pieces of Legos to create your IoT application, all the way from device management up to triggering workflows and other processes in your line of business application, and back to the devices, obviously. And we'll talk about these platform services today. And then we have the edge area. And edge covers a lot of things. There's Azure IoT Edge, which is a framework that allows you to run cloud compute onto the device, but also to manage an application on a device from the cloud, from Azure IoT Hub. But we also now talk about Azure Sphere or Windows IoT as part of our edge story. Edge is anything that is not on the cloud, that is device, right? So let me dive a bit more into details about what these are, right? Solutions, I mentioned Azure IoT Central. And we have IoT solution accelerators as well. On the edge side, Azure IoT Edge that I mentioned today. These will be covered in these two other sessions, right? That are later today for the IoT Edge one, and on day 3 for the solutions session, right? So I will not dive into too many details here. It's already covered. On the platform services side of things, Azure has tons of PaaS services that will help you building your app in the cloud. These 4 ones are the ones that are really tagged IoT, which doesn't mean that you cannot use other services, such as Azure Functions, Stream Analytics, and others in your IoT application. Azure IoT Hub is your gateway to the cloud for devices. That's the gatekeeper, that's the one that authenticates devices, that's the one that holds and maintains the digital representation of your device in the cloud that we call device twins. That's the one that you will interact with to manage your devices using some of the primitives we'll describe today. Azure IoT Device Provisioning Service is that service that will allow you to provision devices at scale, at an IoT scale. And we'll get into some of the details about DPS, and I'll show you a little demo of that. Azure Time Series Insights, oh, I'm going too fast. Time Series Insights is about exploring, analyzing time series data. When devices send telemetry data up to the cloud, they usually stamp that data with a time in it, so that actually you can rewind in time and see what the data was some time ago. And we will dive into time series insights and show some cool demos, especially for developers with things that you might not have seen yet. Azure Maps, we actually had location-based services. You might have seen Chris on some of our Azure Friday videos or the IoT show talking about the Azure Location-Based Services. It's now called Azure Maps, and you'll know everything about Maps in a second. Don't forget to grill him. Azure IoT Hub. Let me dive into this one. So that's your gateway for devices to connect to the cloud. It's one PaaS service. You will instantiate that into the cloud, into your Azure subscription. We have various queues for this service. We have a free one that actually allows you to send 8,000 messages a day. And then we have paying ones with different tiers. I'm not going to get into details there. We have our fantastic marketing and other PMs for IoT Hub on the booth. And you'll be able to get some information from them about the pricing. But basically, you can go very, very cheap on connecting your devices to the cloud. We actually recently, in that one, I want to mention that, we actually created a new basics queue, which intends to address scenarios where you don't need to do anything else than send telemetry message. Lots of customers were using Event Hub for that because it was way cheaper than IoT Hub. And instead of making Event Hub more expensive, we made IoT Hub cheaper. And that's basics queue allow you to do telemetry and authentication. So you get all the goodness of Event Hub, which is low price, but you get all the goodness of IoT Hub, which is safe authentication and security for your devices. Happy to answer more. So IoT Hub is that service that you'll connect your devices, whether directly, whether through a gateway, right? Because not all devices talk internet. Azure IoT Hub is a cloud service. It needs to have a internet connection in terms of connecting the device to the cloud. If you use a field gateway, that field gateway will be the one that will interact with IoT Hub on your behalf or on the device's behalf. These devices will connect to that field gateway using field bus protocols such as BACnet, CAN, and others. What you can do as well for devices that don't talk any of these protocols, or you don't want to have a field gateway, you can actually instantiate your own cloud protocol translator. In the cloud, we have some samples for that. Last but not least, you can do all of that together, a field gateway that doesn't connect directly to IoT Hub, but uses a cloud gateway. We're seeing less and less, actually, customers willing to have this cloud gateway because they want to have more and more of the devices connected directly or through an edge gateway that can talk directly to IoT Hub. It's easier to manage. You don't have to spin up a VM with that cloud gateway, translator, and at the end of the day, you end up having more to maintain. So that's what's happening on the device side of things. You also have a huge amount of APIs on the cloud side of things for you to interact with that device gateway, right, which is that hub in the cloud. So you can manage your list of devices, you can send messages to devices, you can update what we call the device twins that I'm going to mention and talk about in a little. These management apps and the interactions with IoT Hub as an admin can be done in the cloud from a web app, or can be done from a mobile or PC app, is the exact same way. For interacting with IoT Hub, we provide APIs, obviously, for the service. On the cloud side of things, there are REST APIs. On the device side of things, they're using MQTT or AMQP protocol with an option for HTTP that doesn't give you bidirectionality and doesn't support the device twins and methods, which is something you might want to use. So device side is mostly AMQP, MQTT protocols. The choice is yours. Cloud side is HTTP REST. To make your life easier, we provide open source SDKs for that. And the SDKs are not just wrappers around the REST APIs, around AMQP or MQTT. They're actually way richer than that. They implement a logic for retrying connectivity and sending messages. This is something that is not very trivial on devices. So the retry logic is very powerful in the SDKs, allow you to fine-tune what the retry logic you're looking for. In the world of devices, there's something you don't want to do is retry at the same interval forever. If you do that with your buttons because you're loving the session, you'll see the battery actually is going to die pretty fast. Well, if someone comes back with a dead battery to me, I'll give him a new button. Okay. And we'll send the data about the button clicks to evaluation so that it's going to get the scores out here. That's what we're going to do. I lost my, so open source SDKs, retry logic, super powerful, and devices can implement this retry logic such as exponential backoff with jitter, something that allows you to eventually not have all devices trying to reconnect together, at the exact same microsecond because they are tuned the same way. You want to add some jitter in the way devices reconnect. SDKs take care of that for you. We have SDKs for C. We have SDKs for C#, for Java, for Python. We offer them as open source. We accept external contributions. We support Windows, we support Linux, and we have the C SDK working on many microcontrollers out there. You can leverage an Arduino library as well. We have packages, NuGet, NPM. We are on Maven. We have apt-get, and so on, right? If you guys have seen the VC package manager thingy, it's pretty cool to just now support Linux, and we're working with them to have a VC package as well for our C SDK. So that's the SDK, that's Azure IoT Hub. Once you have devices connected and you can manage them, well, hook that up to anything. So the IoT Hub exposes endpoint one default endpoint, which is an event hub endpoint. They can actually just get high throughput of data through. But then you can create these custom endpoints. You can add more event hubs. You can also add endpoints such as storage, or you also have service bus queues and topics that you can add there. And we're working on having integration with event grids as well, so that you can have IoT Hub being a provider to event grid scenarios, where you'll be able to trigger something in event grid from IoT Hub. So that's the way you're going to integrate IoT Hub in the rest of your application. You're going to look at these endpoints, you're going to create new ones when you need some, and you're going to hook that up to the rest of the world. We have a feature in IoT Hub, which is called routing, that allows you to go into the messages that devices sent, and eventually also their device twins. And based on that content, you'll route the messages. So if you have a device that is sending a message that in the header has a alert tag, you can set a rule in IoT Hub that says for every messages that has this tag in the header of the message, I'm going to send to that specific endpoint. So then you can create advanced rules where you have alerts eventually that are managed in a hot pass, like immediately trigger a flow. And things that are not alerts, that are more telemetry, you don't care about, or you want to come to later, then you can actually funnel them to a storage, to Cosmos DB, or to something for later analytics, or actually to come back to them later. So you can do that with IoT Hub. No need to hook up your own application. Behind it will filter the messages. That is done in IoT Hub. And IoT Hub can do that at a very high throughput, can only go and open the messages, look at the content of the messages, and supports various formats like JSON and others. And we'll look at what's in there, and we'll determine the scoring on the rules you set based on that content. And so you can imagine we're talking about IoT scenarios. That's a huge amount of data that's going to come up. The IoT Hub service can ingest that and can also analyze that on the fly. Automatic device management, there's the theater session that's going to talk about that. This is a new thing that we have which builds on top of the twins that allow you to do this configuration of devices in an automatic way dealt with by IoT Hub. So I invite you to go to this session. It doesn't have buttons, but the guy is super cool, still presenting really well what this is about, and you can grill him on questions about device management in general. Because once again, Chris Green was presenting that is the PM for device management. Okay, stop talking, get to the demo, unlock the machine. It doesn't recognize me, that's funny. Okay, I'm number 6, right? So the first thing I want to do is show you how you can create an IoT Hub, right? That's the basics. Some of us like to go through the portal and do create resource, select Internet of Things, pick IoT Hub, and go through the full thing. I'm not one of them. Oops. What's going on? Let's try again. I'm still duplicating. Let's try and switch here. No, no. Yeah, it's weird because I was number 7, I'm number 6 here. As long as we have a screen, I'll be happy, right? Or not. Can someone come over for the AV problem? Oh, oh! Stay away from it, right? It's written up there. Can someone help me? Okay. That's going to not help for demos. Or you all come here and watch my screen. All right. We'll do live plug-in, plug-out. Do we have a other? I have only one HDMI. Fantastic. Live demo, guys. And I'm not dancing, promise. Okay. So I was saying it did burn some of my demo, or actually some of Andrew's or Chris's, because they are behind me, so I can. So I'm not that portal guy. You might be. The portal has all the options. It's one thing at a time. I actually invite you to go check out the Azure CLI v2. So we have a IoT extension for Azure CLI that will allow you to deal with hub stuff, with device stuff. It has both control plane and data plane, so you can actually work with devices or simulate a device, send a message, things like that, but you can also manage your IoT Hub. You can create new hubs, create device identities, and all of that using Azure CLI. We also have PowerShell support for the control plane stuff, and we're adding the data plane stuff soon, so you'll be able to do all of that as well. So if I look real quick at some other ones, on the device side of things, you'll see a bunch of commands here that are about creating device IDs, listing the device IDs on a specific hub. You can simulate your device, so that means you can actually set a JSON piece of information and simulate a device sending that JSON on a regular basis directly from command line using Azure CLI v2, right? So that's pretty cool. That's an extension that you can find to Azure CLI. So have a look on GitHub for Azure CLI extension for IoT or Azure IoT extension for CLI, something like that, and you'll figure that out. So once you have an IoT Hub, you have one way of working with it, which is with a portal, once again. In that portal, you'll be able to look at what's going on in terms of the device connected, the data that is going through, and you see here I have 400,000 messages allowed daily, so I'm paying for that IoT Hub, even if it's just for demos. You have the shared access policies, which is interesting to look at, because that's the part where you define who can access on the service side of things. We can change a device registry. We can send messages to the device from the backend. And this is dealt with this shared access policies. Devices on their side, they're managed through this IoT Devices Explorer. And in there, you have all the device identities that have been created. Obviously, I have only 2, so I don't need to use the queries. But if I had to, I would be able to assign tags in the device twin. So device twin, just because I'm mentioning that a lot, device twin is that digital representation of a device. It's a JSON file that is maintained by IoT Hub, and that is synchronized each time a device connects. And it has a notion of tags, which is a property that only the backend can see, not the devices. And that allows you to group devices and to address them in groups, and eventually to query them in this tool, or in your APIs or in the SDKs. And then you have a notion of reported properties, which is what the device says it is reporting as a state, and desired properties, which is the set of properties you want the devices to apply, right? So what's going on is that the device will connect using the SDK or not, but using the SDK is better because you don't have to code all that logic of synchronizing that JSON file and dealing with differences and so on. And the backend actually will synchronize it well with your application by notifying a new reported properties arrived. And one important thing about device twin is about the last known state of a device. If a temperature, for example, reported through twin changes 3 times while the device is offline, when it comes back online, you don't have the history, you have the latest value, right? And that's very useful for things that are actually not a telemetry-based thing, right? So twins is really about state of a device, last known state, or desired property. So next time the device will connect, it will apply that desired property you chose. If you change it 3 times before the device comes back online, it's going to actually just apply the last one. Make sense? OK, and I will show you a little bit about device twin. So you can here query your devices based on these tags in device twin. I will not do that. What I'm going to do actually is connect an IoT button. Another way to deal with the IoT Hub is to work with VS Code. And there's 2 extensions. How many of you are using VS Code? OK. I hope the other ones will actually start adopting it today. So VS Code actually has a great feature. It is cross-platform. And in the IoT world, people working on devices, well, they very often are on a Linux machine or a Mac, and so we have to have a tool that allows them to work with their devices on the platform they're using, on their laptop, on their machine that is running whatever it's running. So VS Code is a good way for us to develop these tooling in a cross-platform way. We're not forgetting Visual Studio. We're actually also working with Visual Studio team actually to have all that support up there. But today we are a bit more advanced with VS Code. One of these extensions is called Azure IoT Toolkit, which totally aligns with the title of the session, right? The toolbox for the IoT developer. That one actually will allow you to do everything that is IoT Hub related. Create new devices, list the devices, get the device twin, all of that, and you'll see how in a second. And there's another extension that is called the Azure IoT Workbench, which depends on the IoT Toolkit. That one might or might not be available today. The DevDiv China team released it on GitHub, so you can actually download the VSIX file and install manually on your VS Code. It should be on the catalog on the marketplace for extensions real soon. And this one actually is a work in progress experiment for delivering an end-to-end experience for developing on devices, all the way from creating code for the device, debugging the code on the device from VS Code, and then creating an IoT app, which is a composition of several PaaS services, like Azure Function and others, with IoT Hub in the middle, and deploying from VS Code these solutions. Let me show you how that works. So what I'm going to start with is invoking some of the command palettes commands, and I'm going to call IoT Workbench new, and I'm going to create a new project. And this new project, I'm going to put it here in a new folder, and I'm going to call it session demo. Select the folder, and I want to select one of the devices. Today we support 2 devices. There is the MX chip dev kit, and since yesterday, the button. Right? So the button actually is something you can work with Workbench, and you'll see how in a second. So I'm going to pick the text mode button. I want a solution that's going to have IoT Hub Plus function. Today, we only have these two templates, IoT Hub only or IoT Hub plus function. We'll add more along the way. And this Workbench tool actually is open source, so if you want to contribute more, help us, guys. So I'm going to have one with Azure Functions. I'm going to skip the choice of a storage account right now. And I'm going to dive into my new project. And as you can see here, I have a section which is about the device. For the button, there's no code in here because the code is already here. It's just a configuration. So I have a user data JSON that I can change. And what I can do in there is eventually type something like button ID in there. And as usual, if someone sees some typo in here, they should tell me, right? Button ID will be demo button, and I can add something else like Twitter handle, and in there I will just write that. Okay, so that is the way I'm configuring my device. Well, actually, I'm setting up data that my device will be sending each time it connects to the IoT Hub. And then I have my function itself, and the function here has a trigger. And this is code that I'm going to then deploy onto that subscription. So what I will do is show you from Workbench how I'm going to work on all of these. On the cloud side of things, the first thing I'm going to do is provision my services. I need to provision an IoT Hub and an Azure function. So I'm selecting that. I can pick an existing IoT Hub or create a new one, right? So if I want to create a new one, I go down there. I use the existing one to save some time as well. And I'm going to go to this device product team, and I'm going to try and pick the one that is called Olivier Hub, because it already exists. The next thing is it's going to ask to create a new device ID in that IoT Hub. And I will do that. And I will create a new device ID, and I will call that demo button ID, for example. And what I will show you real quick here is that I have my extension, the IoT Toolkit, connected to my IoT Hub. And it's actually displaying the device ID for that IoT Hub. And I see IoT demo button ID here, which has just been created. So that's pretty cool. I can see what's going on my hub without bringing up the portal. Very useful when you're developing. The next thing is going to be about the Azure function. So I'm going to go on this subscription again, and I'm going to pick build 2018 session demo IoT, something unique. Hopefully no one has picked that. And I'm going to work on the same resource group. There should be one. Well, I picked the wrong. Oh, that's OK. Oh, hold on, guys. I think I'm the wrong subscription. I'm going to mess up with someone. OK, I'm going to select create a new one. There you go. And I'm going to pick a storage account, or actually create one with that name, and it's going to be in Asia because we can. So that's actually going to spin up a new Azure function, and it's going to be ready for me to deploy from that tool as soon as it's finished, right? For the sake of time, what I'm going to do is switch to one that's already deployed to not mess up too much with someone else's subscription, because I think I'm actually working on someone else's subscription because I didn't pay attention. I'm going to open that other workspace that has been working a few minutes ago, and that has exactly the same situation, but the function has already been provisioned. I here have button ID, Twitter handle in my user data. I've been playing around with my Twitter, with my function. The function right now is just invoking an HTTP trigger to trigger a Microsoft Flow. You would ask me why Microsoft Flow? Because I can. And this flow actually is very simple. It's just going to post a tweet. So when I trigger this guy here with that URL, it's going to post a tweet. It's expecting a unique ID and a button ID, button ID and Twitter handle. And it will tweet, hello, IoT world, this is Twitter handle. Just press the IoT button, and here I am. So let me actually go back to VS Code. So you see here, I'm doing this post async. It's using that URL, and it's sending the body of the message. So when IoT Hub triggers the function, it passes over the body of the message received by the device. So function can actually just dive into that and use it, or pass it over to whoever is behind the function. And that's what we're doing right here. So if I wanted now to deploy that function, I would just go to Workbench and say cloud, and I would say Azure deploy, right? So Azure deploy. And it's going to ask me, do you really want to do that? As in, do you know what you're doing? And it's going to actually push that code up to that Azure function. From here on, and what I need to do is actually configure that device. I will not do it because it works. The way to configure that device is to put in access point mode, where you press 5 seconds, the LED turns yellow, blinking, you stop pressing, and then you can connect your browser or your laptop to that access point, and you can set up the configuration through a web page. We also have companion app for mobile devices that you can set up the Wi-Fi, set up the IoT Hub connection string, and set up the little user JSON data thingy for your device. The Workbench tool allows you to do that as well. I can show you on the booth later on if you want to see that. So here I have a function that is ready. IoT Hub is waiting for messages. What I'm going to do from here is I'm going to monitor what's going on from this device. So I'm going to start monitoring device-to-cloud messages. And I'm already running over in time, right, guys? OK, just checking. And so when I press this device, it's going to do something, right? Boom. So the device actually started finding the Wi-Fi. It will connect to the IoT Hub. It will send a message. The message will propagate through a function that will twitch something, right? So let's go. While it's doing that, so message received by IoT Hub. The function has been triggered. The flow has been triggered. And now if I go back here, I should see a new tweet, from this device. Actually, from the flow, right? Boom, 3 seconds, that's the one. It's been triggering this function and then this Microsoft flow. So pretty straightforward and something that you can reproduce at home with that IoT button very easily. Second real quick demo before I'm kicked out is the device twins. I want to show you a very simple example of a device twin. So that's not a device twin, that's me. And yes, that one. OK, but this is the device I want to show you. So this is a little MX chip device, right? So this is one of a dev kit, pretty straightforward to connect. We have some samples online. This one is one of the samples. This device is reporting a state which is displayed here on this little web app. This little web app shows the actual SSID it's configured to. It doesn't show you the password. You can hack my Wi-Fi. But then it's showing the very sensor status and whatever. I can also interact with that web app to set a new device property. And here I can say, hey, turn that LED on or off. And you'll see a little LED here down there is going to turn on as soon as the device is connected, is synchronizes as device twin. The other thing I can do is actually play around with the color of that LED, which is the other one here. So when the device synchronizes the twin, actually I might need to refresh the page here. Let me try that, sorry. Do demos live, guys. It's super important. And let's try again. And hopefully the device itself is still connected. Now, actually, green. OK, my button is green. Let me put red. And come on, buddy. Or not. I'm lucky. It's IoT, guys, so I can just do that. And you're going to trust me, it works. I won't leave the stand until it works. Come and get me. OK, so what I want here is for the guy to say, I'm connected. Can we blah, blah, blah? Yeah, actually, it's green. I want here on this guy here, green, yay! Red, red, come on, red, red. OK, good. So last but not least, device provisioning service. So I had a set of slides, but I'm going to skip them. So device provisioning service allows you to rapidly and efficiently provision tons of devices. So if I have one of these devices, I can flash a unique ID on that pretty easily. I can, if I'm dirty and not secure, I can hard code in my application that connection, or I can flash it in some secure storage on that device, right? And so that would be actually the right way to do. Secure storage, you flash some secure identity, some unique identity that is used by the SDK to create a unique token that will allow it to authenticate with IoT Hub, right? The problem with that, you need to have different identities for each of the devices that you're going to provision. So if you have 10, easy. If you have 200, 1,000, 1 million. It's not going to be that easy. So what we offer with device provisioning service is a way for a device to connect to a universal endpoint to provide a piece of ID which is already provided by the hardware manufacturer. It could be a MAC address, could be a secret seed that is actually flashed into a TPM, or in DICE, or into ST-Safe. In that case, we're using ST-Safe, where we have some unique identity that's been flashed with 64-bit something, and that the manufacturer of the chip itself will provide. So you have that information, that piece of identity, or eventually you have a cert that has been created from this identity, and you're going to put that into DPS in what we call a provision. And what that provision will say is that for that specific piece of information that's going to come up from a device, I'm going to associate that to an IoT hub, right? And so that means that when the device comes live, DPS will ping that IoT hub, will say, hey, do you have an ID for that device? Create one if not, and give me the specific information that it will need to connect to you. Then DPS passes that over, all encrypted, to the device. Device flashes that in some safe storage, and then uses that to connect directly to IoT Hub. So let's look real quick how that looks like into my portal. And I have set up, and still see me. I don't want to freak you out too much. So DPS, here I have an instance of DPS. What I've done is I have attached an IoT hub, which is my Olivier hub here. So there's one of them. I could have several of these IoT hubs set up, and I could then do geo-sharding. I can actually indicate which IoT hub each of the devices needs to connect to. And then I have my enrollments, and I have one enrollment, which is an individual one. I uploaded a X509 cert that's been created with a unique identity that is now flashed on this device here. So this device here has no idea which IoT hub it needs to connect to, right? And actually, as a matter of fact, if I look in here, you can see a set of these devices, and you'll see a new one appearing in a second. So what I'm going to do is I'm going to connect this device. This guy is starting its connection. I don't know if you see, it's all blurry, but it's connecting to Wi-Fi, and then it's going to connect to the DPS endpoint, and then it's going to request for an identity that's going to be created into IoT Hub. And so if I come back here, I will see that, boom, there's a new identity that's been created, MX chip device 1. And the device will start sending data, and we can see it's green here. That means it's actually actively sending data right now. So I was able to seamlessly provision that device by just connecting the red cable. You need a red cable, though. Okay, that's just saying. Okay, just checking you're still awake, guys. So what we're going to do now is we're going to switch. What I want to do, oh, no, actually, no, I have something funny. You guys did press the button, right? Let's see. You did. Whoa, okay, cool. So what you're seeing here is a heat map of when Woo clicked. So here we have, I don't remember how many, but not everyone is actually super active here. We want to have more than that because we gave more than these number of devices. Each time someone clicks, we have a new red dot that appears. So continue, and we'll see more of these, and we'll come to them. So this is actually a time series insight display. And I'm going to hand it over to my dear friend Andrew, who's going to be presenting about TSI. So I'm going to switch this HDMI cable unless... I think we're going to do the switch, unfortunately.
We're just leaving it on this one.
You have the slides, though.
Oh, okay, fair enough.
You want the slides?
I do want the slides.
Okay, sorry for that, guys.
Hi, everyone. While Olivier's setting those up, I'm Andrew Shannon. I'm a program manager in Azure IoT Engineering, and I'm a PM on Azure Time Series Insights. So I'm going to spend the next 10 to 15 minutes talking to you guys about some of what we're working on. I'm going to introduce you really quick to the product. I'm going to talk about some announcements that we've got, and then I'm actually going to jump into some code associated with some really cool developer tools that I think you guys are going to like. So at a high level, Azure Time Series Insights is a fully managed service for time series data. When you think of what we do at a high level, there's really three core jobs. We store time series data, we visualize time series data, and we give you the ability to analyze that time series data. We play super nicely with Azure IoT Hub. We're seamlessly connected and have created our own event processor, so you don't have to build one of those if you want to get started with messages coming in from an IoT Hub. And we also have a built-in aggregation query head on top of time series insights, so it's really easy to do things that you would naturally want to do across lots of IoT devices, like aggregate them. So, a couple of things that I want to call out. Some of you may be familiar with us. We're a lot more than visualization. In general, most of what our customers have done are really at a platform level. We have ABB in their Ability platform who's actually used time series insights at its core to do all time series data storage, the management of that data, and then they populate KPIs using our query head and have their own visualization. We also have companies like Steelcase who've built a smart spaces application that uses time series insights to do all the storage and the querying of that time series data to really take their time series data and make it incredibly powerful and super performant for their users. Now, a couple of things about our storage. We're an in-memory and SSD store today. We're a columnar store underneath that's optimized for time series data. And until recently, we've been able to store data for up to 400 days and about 3 terabytes of data, which kind of makes us a warm store. We're interactive. It's not automatic, but a user can interact with that data right when it comes in. They can slice, they can dice. The data is always hot. They don't have to wait for it. What's really cool, though, is that we've just made a few announcements that we went into preview with some new features. So the first one is that we've added a tag-centric user experience. So whereas today, if you want to start with a device, or if you want to start with a time series, you would filter aggregate to get down to one particular thing. What we've done is we've actually created the ability for a user, someone like a process engineer, an asset operator, a plant manager, to be able to actually start with their time series. So if you have users, you being a developer in the back end for a company that wants to provide a tag-centric user experience to your end users, this is a really easy way to create an intuitive experience for them to be able to quickly get to what they're looking for. Now, underlying this, you'll notice we have a hierarchy. I'll actually get into code here in a second, but we've got a hierarchy on the left, and underlying that hierarchy is a time series model. So if you know anything about time series insights today, we allow you to store metadata, which we call reference data. That's a dumb flat table today. What we are adding in this preview is we're adding a secondary table that's dynamic, that provides semantic lift to this and provides the ability to pass hierarchy in so that you can actually have more context around the data that you've got, which gives it more meaning. Now, the last thing that we've done, and the reason why I brought up 400 days or 3 terabytes, is that we've totally unblocked those limitations with this preview. We've also added long-term storage. And that long-term storage isn't just archival. So now we're warm path and cool path. It's also because you're passing us effectively a type of a tag ID, a device ID, a space ID, whatever it may be that's kind of the key value that determines that device, we'll actually store this data as Parquet files. And we'll give you the ability to query over years worth of data in an ultra performant way to still be able to take advantage of that data that's stored in really inexpensive, cool blob storage. So the product really just evolved, and I want to show you some of this really quick. So I think Olivia's going to flip me over. Yeah, this is the brains.
Let's try that. Let's try it one more time here to see if it works. How long it works.
I think we're going. We're rocking.
What I'm going to do as well.
Thank you.
Fix you, man.
This is my main man right here. Okay, so this is time series insights. We've got some really cool functionality. We've got a beautiful heat map. We've got charts. We've got perspective view. This is time series insights that you would know it today. We have a where clause. This allows you to pass a predicate that filters. We've got temporal operations, date histograms, operators like that. But what we've just added is, again, this hierarchical view that allows me to do both basic search functionality as well as advanced search functionality. So I can go and I can start typing in temp, something that I would expect to be able to do really quick. And I can start plotting these values in near real time. And I'm on a Wi-Fi network, but let's just go through this. We'll plot a few of these values. And I just want to show you this functionality working, because this is actually live working code, which we're really, really excited about. So again, this is tags. This is using a totally different API that we've recently added. And it gives me the ability to do some really, really cool stuff with this data. So that's time series insights. But we recognize that you may not want to use our user experience. You probably want to bake this into your own app, and maybe you've got your own company's application. We've got a bunch of options for you, and one thing I'll call out is that our IoT solution accelerators, remote monitoring, predictive maintenance, including Azure IoT Central, which is our SaaS application, has all adopted what I'm about to show you. And if you want to start from scratch, you don't have an app, you're trying to build an app, it's the best place to start is using one of those solution accelerators. It allows you to start really small, grow it into a big app, and you're using the JavaScript control library that I'm going to introduce you to right now. So what we've done and what we're looking at is a web app that allows you to very, very simply do two core things. One is to make it incredibly easy to query the data that's living in time series insights. So as opposed to writing a JSON-based API, which is what we use, it's simple to use, but you may not want to do that. You may want to write something that's a little bit more like a predicate and expression that you would use in the time series insights explorer. We've actually created a wrapper around our API to make it very easy. I'm going to show you the code on this in a second. The other thing we've done, though, is whether or not you're using data stored in time series insights, if you have time series data that you want to join with data stored in time series insights, we've also provided another method that allows you to very easily visualize in charts like line charts, bar charts, pie charts, heat maps, grids, etc., the ability to render that time series in this if you pass this JSON. So let me give you like just a quick flavor of what we've got here. And I'm going to do a quick time check. OK, so we've got a bunch of different visualizations, as you can see. We've got the ability to do things like right-click. So we've provided a context menu. We've got controls that allow you to lay over time series. This is discrete events and different stages. But when you look underneath this code, what's actually happening is a few really cool things. One is we give you that ability to simplify that code. So let me show you one quick example. If I just flip back over, you'll notice these three graphs. These three graphs, after we've done things like authentication, we've called in the CSS files, kind of the stylistic elements of this page, what you'll notice is this amount of code is all it takes to render those three graphs. And what is incredibly cool is that all we're doing is these three little methods to do a pie chart, a bar chart, and a line chart. And so the power this gives us is to be able to go and start with almost any JSON that is in the form of time series and to be able to start rendering it incredibly easy. So let me jump back into that code for a second. The way just to orient you with this code, what we've got is we're passing in an array. We pass in a to and a from, like what's the time range that we want to look at. We're going to use that to and from across all three of those charts. We have what's called aggregate expressions. Now, aggregate expressions are effectively the call to the time series insights API, our backend. And you'll notice that this TSI client.ux, which is a part of the library, is giving us that ability to very, very easily jump into this to be able to call that data. We have a few properties. Some are optional, some are required. But what we've got here is a very simple way to be able to pull that data. Now, the other thing that we do is we're seamlessly integrated with Azure Active Directory, which matters especially in a managed environment like most of you work in. And so what we've got is above in the code, I won't go through it, but we're using ADL to basically do all the authentication with AAD. What we're doing with this is we have one line of code that's allowing us to grab a token just to make sure the user's authenticated. And then what we do is we pass these two aggregate expressions. We're passing them as a batch, so we can batch as many aggregate expressions as we want to. And once we've batched that, all we're doing is we're passing the token, the AAD authentication. We're passing the environment, like what's the time series insights environment, the URL in which this data lives. And then we're passing the aggregate expressions of that batch. And what comes back is, from TSI at least, is some compressed JSON. And that compressed JSON doesn't render incredibly well in a line chart or a bar chart. And so what we do is we have this method which transforms that result from something that's not incredibly amenable to a line chart and makes it very, very amenable. And so what you'll see is the two different main components of this library are the TSI client.server, which is how we interact with time series insights, and then the TSI client.ux, which allows you to render this code very, very simply. And so, a couple of cool things here. One is it's literally just these lines of code that do a bar chart, a pie chart, and a line chart. Now, what's really cool, and I actually just want to show you this briefly, and I've cheated to make this a little bit easier, but I'm actually just going to switch in real time some of this data. So let me just inspect the elements. Let me jump into the console. I'm going to show you this graph is a line chart. You'll notice this graph too. Well, here is what is really cool. All I'm doing, and just to show you this code, is what I'm doing is I'm going from the line chart to a pie chart. So this is going to change into a pie chart. That's all the code it takes, and I've got a pie chart. It's the same data. It's literally just changing those two variables within the code itself, and I'm able to do this. So for you all, what I'm hoping you see is that, hey, if you're using time series insights, it's really easy to embed it into your own application. It's super easy to keep it in a managed environment because you're using Azure Active Directory, and it takes a significant amount of the burden off of you all to have to code to build beautiful visualizations using your time series data. Now, I want to show you just one or two other small things before I take off. What I want to look at is this code right here. Or this chart right here. What we've got is we've got a legend on the left. We've got two different buckets, incidents and component states. You can imagine this is maintenance on a device. This could be on and off. Incidents are discrete events, something that contextualize it to say, hey, such and such was working on the device at this particular moment, or we had an incident where it went offline. I just want to reflect that. And what we're able to do is all of this is data stored in TSI, but I could just as easily pull in data from, say, the weather service here to make this really, really powerful. And so just to jump back into the code for this particular component, I just want to show you how easy this is. All we've done is we have passed in some JSON. We've hard-coded this, but you could use a console app to do this automatically. What we've done is we're passing in a key property, which is a JSON, a JavaScript ISO timestamp, and then an array as the value, which is color and description. You can do that with any state, and it's automatically going to render on that chart just the way you'd expect. Similarly, you can add brushstrokes, context menus, and as we speak, we're just publishing documentation on this. Now, we're going to keep evolving this code, and we want you to be able to pick this up and quickly and easily use this, but we also want you to be able to contribute. So this is open source. It's an NPM. We've got it on NPM. We've got it on Git. We'd love it if you contribute to this, but we'll keep evolving this, getting the documentation up and running so it's easy for you guys to use. Now, this was a smorgasbord that I showed you, but what I wanted to show you is an example of using this application to build something that would be functional for your organization. And then I'm going to hand it over to Chris Pendleton, who is the PM lead for Azure Maps. And let me just see if I can't get this guy working. I think I've got, well, I'll show this, and even though the bottom is still doing something a little weird, but what we've got here is a Azure Maps in the top left. We've got a bar chart in the bottom left. And what I have the ability to do is import in a process graphic and use time series insights to start to see what the current state is. These values are updating every 30 seconds. I know exactly what's going on with my device. And if I want to, I can always flip into the time series insights Explorer to do a deep dive. What's really cool, though, is this app only took about an hour to build. And of that hour, the Azure Maps component took about 10 minutes. So this is very, very simple to use to build your own custom application, and you can make it even richer by embedding Azure Maps into it. So with that, I'm going to hand the torch over to Chris, and Chris will take you through Azure Maps. Thanks, guys.
Nice, man.
Yeah, thanks, man.
Turn the clicker. Okay, thanks.
On here.
Make sure this thing sees me. Yeah, 10 minutes, newbie. Yeah, should take about 30 seconds, actually, for those of you who've done this before. Thank you for the intro, Andrew. So welcome to Azure Maps. Today, actually, yesterday was the big announcement where we announced general availability of what was Azure Location Based Services is now Azure Maps. And in partnership with TomTom, we have a fully running stack of mapping capabilities built natively into the Azure cloud, fully available to developers. So now we have a developer platform that is backed by one of the largest mapping companies in the world, in TomTom. And the services that we offer are pretty robust as our V1. And so right out of the gate, we've got almost a complete global coverage of map data available in full vector form. So we're rendering information from the global database from TomTom in the Azure cloud down to clients through vectors. And I'll give you some demos of that. We're shipping a JavaScript map control to make it very easy. That's what Andrew was showing. I'll walk through the simplicity of the implementation of that. We have a very robust routing service. So routing is different in the Maps world than in the IoT world. So routing is basically directions. With the directions come some pretty complex algorithms behind them, taking the data and providing directions both A to B, A to C, A to N, N to N, and lots of different algorithms that we're shipping as a part of that. I'll talk about that in a little bit. Search and geocoding. So search, we've got a huge corpus of place data, place information, as well as business listings. And so the business listing information is probably the hardest to keep up. Businesses open, close all the time. Hours of operation vary throughout time as well. And so we're making an API available globally for that data corpus. Geocoding is converting address information to latitude, longitude coordinates. We're making that available as well as the reverse. So if you have a coordinate, we can tell you what the address is or go up hierarchy and figure out street name, postal code, city name, things like that. We also have best-of-breed traffic. This is where things get pretty interesting, and there's a bit of a crossover with IoT. As it turns out, maps had been made through drawing over aerial photos for so long, but with the widespread adoption of sensors, including the one that you're driving around in every day, maps tend to be more flexible in auto-generation or regeneration. And so as we start to get a penetration of massive amounts of sensors, map making actually gets pretty interesting because we can start to automate how maps are created. So for example, as we start to detect GPS sensors traversing down a road at 60 miles per hour, and we don't have that road in our database, we can infer that there might be a road there. We need enough evidence to do that, but if you can imagine the penetration of sensors that are now filling the world, and most of them have a GPS, we can actually automate map creation. And so what we're trying to do now is use IoT sensors, IoT capabilities for communication to effectively auto-generate a map and do that at scale and do that globally. Traffic was sort of the first example of that. Traffic generation was actually done by movement, and over time you look at the history versus what it's actually looking like right now, current traffic, and that's how you determine the difference in speed, and you can annotate traffic as red, yellow, and green. Finally, a time zone API. I'll talk about that a little more detail. But effectively, if you've got a location, we'll tell you what time zone it's in, what the offset is to GMT, and what time it is there. So general availability, fully integrated into Azure. The simplicity of adding an Azure Maps account to your subscription is literally go through the Azure portal, click, and you're in. If you have an Azure subscription, you can do pay-as-you-go. Super easy to get a key. It's all key-based authentication. Pass in a key to the REST services, and off you go. So what's new for GA? For those of you who were familiar with Azure LBS prior to today, a little treat for you. So we've got a new API that returns static images. So that's pretty useful. A geometric search for places. So you can actually pass in geometry to specify a region for searching. I'll demo something like that. A nearby search, which is a radius search for business listings and things in an area. So given a point and a radius, you'll be able to extract business listings like gas station, pizza places, coffee shops, bars. And then searching along a route. So given a route, we can create a buffer around that route, which is sort of old school. But we actually initiated the actual driving calculation. So if you see a gas station off to the right of the highway and you think that's the closest one, guess what? There's a 30-mile lake in front of you, and you have to go all the way around. So as the crow flies doesn't always work, and so you can do either a buffer search as the crow flies, or actually use the actual route geometry in your calculation. We localized the time zones in 30 different languages. That was the immediate first piece of feedback, was that our time zone information wasn't localized, so we implemented that. And then we added accessibility support for our map control. So the map control actually will be read by a narrator. It will tell you that there's a map app, a map container. It'll take the center point of the map and tell you what the center is that you're looking at through a string reference. So let's take a look. Thanks, sir. Maybe. I'll try it again.
Yes.
All right. So this is what the canvas looks like. This is just our map control loaded up into a web browser full screen, fully manipulative. So we colored it with Azure-specific colors. Usability has played a part. Accessibility has played a part. There's a lot of thinking that actually went into the design of this map. And again, it's vector drawn on the client. We've got some listeners on the client, so if you click, you can add pins. You can rotate the canvas. We could do 2.5D. All of this is fully available, and you can annotate it with layers as well. So, and I'll demonstrate that in a second here. So just to give you a visualization of what Azure Maps looks like, it's sort of a reinvention of maps within Microsoft and how we want maps to look inside of the Azure cloud. It's an acutely focused platform on developers and enterprise customers. And so we are taking Azure Maps to our enterprise customers. We're focused on IoT scenarios, but as it turns out, IoT is sensors, which is in vehicles. It's also in satellites and space. And so I get to play with everything. And everything that, as it turns out, happens on this planet needs some kind of planetary reference. And so we've got a new Maps platform inside of Microsoft. So let me take you back for a second, and hopefully I can get back, to the code walkthrough here. So Andrew mentioned 10 minutes, but really, this is all the code you need. I stripped it out of all of the stuff that you may not need, but just for a hello world application, I mean, we're talking about 5 lines of additional code to a basic web page, right? At the top, you're linking to our style files as well as the control itself. You could download those, modify them, but at your own peril. Add a div, pass in your subscription key, instantiate the map. Pass in parameters for the map. Super, super simple to do this in JavaScript, and all available in general availability today. So let's go back to demos and look at some of the other fun and crazy things that we can do here. So I've got a demo here for polygon. So I mentioned there's listeners on the map. If I wanted to just draw a polygon on the map, so first of all, I clicked the map and it added a push pin. What that did was, in that click event, I listened for it, I grabbed the pin, I actually instantiated a pin object, I instantiated a layer object, and I passed that layer on top of the map. So now I've got a layer above the map that's got this black pin, if you will. And as I continue to click around, I can do sort of whatever shape I want here, and then draw a polygon. And so now, what I've done is I've added push pins, and I've added a polygon, and I've added them on the same layer over the map. And so what I could do with this is actually extract the coordinates and make a spatial query to a spatial database. So if there are things here that I care about inside this polygon, maybe IoT sensors, I can actually then take that information off of the map and send it to any kind of spatial database that accepts lat longs. And when I talk about layering, we've got quite a few layers here. This is just some demo applications that we've built. I used to, I'll turn on traffic flow here, but I used to have to go to LA for guaranteed traffic, but traffic in Seattle's gotten pretty rough over the last few years. Again, this traffic information is near global. It's available in 65 countries at this fidelity. Out of the gate, I can turn on incidents, so I can see where there's potential accidents. So I've got some construction. Here's the real reason. We got a lot of traffic here, a lot of construction going on. And then I could turn on POI layers and things like that. And again, I'm looking at listeners. So because of all the traffic, I really just want some bars around here. Let's look at another thing here. So interactive search. So this is querying the search API for business listings, for points of interest, for addresses. If you don't know what the user's going to look for, we have a fuzzy search. It's basically send me your garbage, I'll figure out what it is. So I can just search for something like gas stations here. It does ship with an auto-suggest feature as well. And so you can see here we've got detailed business information for gas stations in LA, for example, here. All right. And then one other demo I wanted to show you before I move back to the deck is our routing. So the routing is actually super robust. I mentioned that, but it also supports commercial vehicles. And so the idea is that a commercial truck company, or any kind of commercial company, that has specific types of payloads can use this routing service to determine the best route for them. So for example, and these are just a few of the parameters. We're sort of short on time, so let's say I want to carry some explosives from Seattle to maybe Salt Lake City. I can route, and what you'll see here is the blue line being a car route, so that's the most optimal route if you're driving with you and your family, but Oregon ain't having it if you're carrying explosive through their state. So you're going around Oregon. But the idea is that we've got the route geometry annotated with commercial vehicle information. It could be grade, it could be road speeds, it could be the types of payload I mentioned. So we've got quite a few hazardous materials annotated onto the road geometries as well. And as I mentioned, we're getting into a world where the map creation is automated. At this point, for those of you who've ever been in maps, it used to be a quarterly drop of map data, the whole globe. You'd get it one quarter, and then in 6 months, you'd get it out, and you'd miss 2 more quarters. In our relationship with TomTom, they're publishing every week. So we're now down to weekly updates of the base map data in Azure for Azure Maps, and we're moving even faster. As you can imagine, we're starting to get more and more sensor input, and the maps are getting higher fidelity faster. So that's some good eye candy for you guys. Let me switch back. So in relationship with time series, these things happen. Like Andrew and I have met twice in our whole lives. And as we're sitting here, we're like, we should work together. And so conveniently, with this time zone service, I wanted to illustrate that under the Azure One API moniker, we structure our APIs very similar. And so Andrew and I are sitting here saying, we should build this together. I've got time zone data, you've got time data, why aren't we working together? So the connection of space and time often happens at serendipitous opportunities, such as like today. So if you see some kind of intersection with the time series team and a deeper integration with maps, you were here when it happened. And so the time zone API, it's pretty cool. It was actually a funny story that it happened over Christmas break. I was like 4 months on the job, and I said, why is there no time zone API at Microsoft? Well, we went and created one. And we took Iona data, we took Windows data. So Windows had its own time zone data. Iona's open source. And then we took polygons from our legal team and basically lashed them all together and came up with a pretty robust API that's getting a ton of adoption. And so talking about the structure of this, you'll see atlas.microsoft.com. That's effectively our host name. And then time zone being the actual service name. So I point this out because the structure of our REST APIs is the same. You'll find the service, or you'll find the base name, you'll find the service, and you'll find method. The JSON is the output type. The API's version is the version number. And then you'll find query. And query is the key across all services. And so whether you're on search service and you're searching for something, you put in the query. That's where you put in your query. For routing, that's where you put in your query for routing. It's a unified Azure One API that you'll find across all of Azure Maps, and in fact, across all of Azure. So as you're developing your applications, it's very easy to start working with the REST APIs for Azure Maps, and then the REST APIs for other services, and integrating the two pretty fluidly. So I think that was... I do have a shameless plug. So backstory, Olivier gave us each 20 minutes, and then he said, hey, can I have some time back? And I also have to close. So I have a session tomorrow to dive deeper into maps. If you guys are available for that, would love to see you there if you're more interested in getting deeper with maps. So
Cool. I think we have, so we also have this slide here with all the sessions for IoT. You'll be able to download that. You can find that on the app as well. One more thing, complete the evaluations. The button doesn't work for evaluations, right? You got that, right? Okay. And a couple links for you guys. IoT Show, shameless plug as well, right? This is the one that we have on Channel 9 that we talk about what we're doing at Microsoft, IoT stuff. And now we have a new website called the IoT School that is basically built on the same platform as the AI School. The idea is to have your own learning, end-to-end learning experience at your own pace for everything IoT. We know that finding content across videos, documentation, reference, whatever, and tutorials is hard. So we're making it easy through the IoT School, beyond the fact that we will have a cool sticker at some point. That website actually is pretty interesting for you to discover IoT, but also now to learn more, because we're going to add new learning passes that are going to be more in-depth, and we're going to connect that to our certification program as well. So for now, it's not connected, so you cannot be certified by going through these trainings, but in the near future, that's going to be the case. You'll be able to actually hook up into our certification program and programs for IoT through the IoT School. So we literally are running still backwards, so it's still good, right? We still have 3 minutes for some questions. And literally, I have 2 buttons for the 2 first questions. Good questions. Right here.
I'll get it under 10 minutes at some point. I said I'll get it under 10 minutes at some point.
Damn it, am I going to give a button for that question? That's it's called MX Chip, and that's one of our dev kits. If you go to our catalog, so if you go to catalog.azuriotssuite.com, you'll find information about our dev kits, and this is one of the dev kits up there. Yep. Here, oh, sorry.
Xamarin, good question. Likely. We haven't committed to Xamarin, but we have committed to other mobile operating system platforms. So, but Xamarin's a question mark for us. We are actively working with that team to figure that out. Yeah.
Oh, still questions? Here.
Right now, it's JavaScript, but we'll be going after Android and iOS as well.
Here. I think that's coming, so we would have to, a colleague of mine, Ranga, might be on the booth today. I can get that answer on the booth for you today, later in the afternoon. I don't have the answer right now. Yep.
Is Azure Maps tied to Power BI as well?
Not right now. It is not.
Will it be in the future?
I can see that happening.
Remember, they work in space and time.
Right.
Yeah. How would you, so if I understand correctly, if a device is lost or compromised, right, how do you know it's not a good device, right? So you have several ways to do that. Whether you know that this device has been compromised, in which case you know which device ID to deactivate in IoT Hub. In which case, when you deactivate that, you can delete the device identities that will never connect again, or you can disable the identity to block the device from connecting to your IoT Hub. So that way the device is unusable. Now, if you need to identify that the device is not in the right place or location, that's your own logic that you can actually implement behind IoT Hub, looking at the data. Like, for example, you can actually use Azure Maps to detect that your device is not in the location it's supposed to be in. And in which case, the device sends its location data. In the back end, you retrieve the data, you have the location, say, well, this one is actually not in the right location. Let me deactivate that device ID until I get the physical device back. Does that answer your question? Yeah. Oh. The button itself here, actually the identification is done through a set of settings. So you put the device in access point mode, and then you have a web page or a companion app where you input a connection string that's coming from IoT Hub that has that identity. So that's manual for that one. It's a simple device just for proof of concepts and demos. And basically, you have a manual setup of that identity on the device. So we're not tracking you. You're good, right?
I may be tracking you, but he's not.
So how does the Azure Map relate to the Bing Maps SDK? Will it replace it? If I'm found a new solution which needs map and layers, which one do you recommend using?
Well, I recommend Azure Maps.
No bias, no bias.
And he has no shame.
So yeah, I do have no shame. So there's no current plan to replace Bing Maps. That will continue on. We have a thriving developer ecosystem on Bing Maps. The approach to Azure Maps versus Bing Maps is really, we want to target our Azure customers. We're having all of our Azure customers who are coming to Azure that have requirements from around the company, including those that use Bing Maps. We want them to have location services available to them when they arrive. And so my personal opinion, my professional opinion is I would get on board with Azure Maps if you're starting a new project. Azure's a fairly significant focus of the company these days. And IoT is an acute focus for Satya. So I think your best bet is,
Hint, wink, wink.
yeah, your best bet's Azure Maps.
Yes.
How much data can time series really deal with?
So again, today the data is up to 3 terabytes. What we've just gone into preview with is realistically whatever Azure storage can hold. So it's on the order of 500 terabytes. We will get into petabytes. We'll add additional cold storage layers underneath as well.
Yeah, you're talking about what's up there. You don't really have an issue with data per
Throughput, you mean? No, it's an overall capacity. I mean, it's a very performant data structure that enables us to do the querying that we can do.
Good stuff. Thanks for inviting me.
Sure.
Hey.
Slide back up with the schedule of IoT.
Yeah. So that's 2 or 3 slides back. Hi.
Yes. Yes. It's one of the projects. If you go to the MX chips.
Yeah. With time series insights? Yeah, so so if you go to our URL, which is insights.azure.timeseries.com, /demo, you're gonna land on a data set that you can query from today. Yeah. Yeah, absolutely. If you go, so again, we'll have documentation posted on this, like it was posted at 10:30. You can go, that data is tied to that demo data set. So you should be able to go use, if you wanted to build your own web app using that control library that we did, you can use the data that's living within time series insights. About that is you can actually look across them both, see what's in the TSI Explorer, and look with the JavaScript control library to see how to use the API. Yeah. So we have like on a microsecond, using our API, we have a microsecond 10 concurrent query limit today. We're working to, as we go into public preview with a new feature set, to blow that away and to just make that more scalable. In theory, people can hit that. In practice, we haven't seen anyone hit that.